right, well, as we begin today, if you would go and take out a sheet of paper, and on your paper, go ahead and use your straight edge to make a pentagon. Make it a good-sized pentagon. 5 sides. It doesn't have to be a beautiful pentagon necessarily, just as long as it has 5 sides. And they're long enough that you can actually work with this figure here. And go ahead and call the pentagon A, B, C, D, E. In our last lesson, we did construction 22, which was to transform any polygon into a triangle. I wanted to review that construction with you very quickly here. I want to transform this thing into a triangle. By transform, we mean to change the appearance of it without changing how much stuff is inside or without changing class V, area. So we're going to keep this area, but it's not going to be a pentagon anymore. It's going to be a triangle. What do we need to do first to transform this into a triangle?
Diagonals.
Good. We want to start with the diagonals, specifically the diagonals from the
Vertex.
top vertex down to the
Other
base.
Yeah.
Down to the base. So top vertex down to base. Now, this is not that construction, remember, where we go at one base vertex and draw all the diagonals we can. That's constructing a similar polygon. We're not going for a similar polygon here. We're trying to completely change this into a totally different polygon, that is, a triangle. And I like to number these angles at the base, not these angles, the kind of outer edge angles, if you will, 1 and 2, because our next step is to copy these 2 angles so that we can construct a couple of parallels. And we want to put a parallel right here through each. So I'm going to put a little 3 right here. So we want to make 1 and 3 equal, and 2 and 4 equal. So if you would, go ahead and copy the angle at 1 and then the angle at 2. Remember, make an arc across 1, and then make an arc outside the polygon from E. An arc there, and out there. Okay, so making your arcs. Kendall, were you able to watch the video from the last lesson so you remember doing this? Good. And measure across the angle 1, come outside the polygon to measure angle 3. Make that parallel come down. And then measure across angle 2. Take that same measurement for 4, so we can make a parallel come down from C. All right. Someone besides Chris, what is our next step? Extend the base via Genesis. We want to come out with the base, and if there's a diagonal on both sides, we'll extend the base both directions. Because the key is the base has to hit these parallels. So, line up the straight edge. And I'm going to call these points here X and Y. All right, someone besides Chris in Genesis, what now? Nope.
When in doubt, go to big long line, I guess.
Okay, Chris or Genesis?
Connect X to D.
Good, X to D and Y to D. D is the vertex of the triangle, X and Y are the other 2 points. And all you have to do is connect those dots to form the triangle. And now X, Y, D will have the same area as A, B, C, D, E. So there. Is my triangle. Good. Questions on construction 22? Quickly wanted to review with you construction 21 as well. Construction 21, remember, was to take some triangle and transform it into a square. Now, this construction was rather, I don't know, vague, if you will, in the proof of it. There was a lot of convolutedness. This is very straightforward. You're taking a half base altitude, remember, and making it become, or making it equal, a side square. So remember what we do is we take our compass and we do the perpendicular bisector, remember, to find the midpoint. And once we did, that would give us half the base. We would then do the smiley face construction to get our perpendicular, our altitude, and we would set up a proportion, where I would say that half b is to s as s is to h. And of course we draw our big long line, and we would actually construct this mean proportional s. We'd measure our half base, mark that off. We'd measure our altitude, and we'd mark that off. And right here we'd make a little perpendicular, remember? And then we'd bisect, not that, but all of this. We'd open the compass up and we'd put our perpendicular bisector to the midpoint. And we found the midpoint so we could draw a semicircle. And we put the semicircle across here. And this would be the measure of our side. Since we already have a right angle, we'd measure it, mark it off, mark it off, mark it off, and we connect the dots. We'd have a square equal to the triangle, remember? Well, we could transform other things in a similar way. On your paper, if you would, go ahead and draw any line that's somewhere around maybe 1 to 2 inches long. Draw a line somewhere around 1 to 2 inches long, and then make an acute angle with that line, with another line that's a little bit longer than the first one. So start with a line, 1 to 2 inches, draw an acute angle with a line that's maybe even a little bit longer than the last line.
Does it matter how acute?
I'm sorry?
Does it matter how acute?
No, it doesn't matter at all. Good question. All right, if you would measure, not necessarily the first line, but measure a distance maybe a little bit less than that first line. Make an arc, and make the same size arc up here. Then come over here and make the same arc, and up here and make the same arc. What are we constructing, class?
Angle bisector.
Well, we could make an angle bisector, but really, if I were to connect the dots, I'd be making a, not just a parallelogram, a rhombus, because all the sides would be equal. Though, if you were to, listen, connect the dots this way, you would be making an angle bisector. And you'll recall that in a rhombus, the diagonals do bisect the angles, don't they? All right, so here's our rhombus, and I want to turn this rhombus into a triangle that is 2 times as large. I want to turn the rhombus into a triangle that's twice as large. Now, this isn't a memorized construction. This is done very similar to what we did before. So true or false, class? I want RH to equal T. Is that true or false?
False.
False. The triangle is going to be twice as large as the rhombus. Listen to that again. Think algebra. Triangle is going to be twice as big as the rhombus. How do I need to edit this?
RH equals 2T.
Triangle is twice as big as rhombus.
RH equals V.
2RH equals triangle. If triangle is twice as big as rhombus, does that make sense?
Yeah.
But otherwise, you'd be saying the rhombus is twice as big as the triangle. No, the triangle is twice as big as the rhombus. Do we understand now? All right. Now, for our triangle, we're going to be given the base of the triangle. So come over here if you would. And since the triangle is going to be twice as big, it's going to be a pretty big triangle. So make a pretty good size line, maybe 3 to 4 inches long. And this is going to become the base of my triangle. Now, just like our other transformation used area formulas. So here we are going to use area formulas. In place of RH, I could plug in the formula for the area of a rhombus. Genesis?
RH equals B1.
Help her, Ethan.
D1.
Oh.
D1. D2.
a half d1, d2. And of course, in place of t for redemption, we could put,
Oh, triangle equals half each.
there we go. Do you see what we're doing here with area formulas? And you realize you could do this with any figures you wanted. You could do twice as large, 3 times, doesn't matter. You could do any sort of transformation if you know the area formulas for those figures. Well, right off the bat, I notice we have a 1/2 on both sides, actually. Let me do that instead. Let me multiply both sides by yet another 2. So that twice d1, d2 equals bh. Do you follow the algebra here? Halves are annoying because if you have halves, you have to bisect things, don't you?
Mm-hmm.
I don't like to bisect things. I'm lazy. Right? Which means, by the way, that whole half bh equals side squared. If you multiply both sides by 2, but they get a 2 side squared. Oh, never mind. You can't construct a mean proportional then, can you? So we had to do the half here. But here, since there was a half on both sides, I could get rid of it. So here, what we want to construct, do I know diagonal 1, class?
No.
Could I draw it?
Yes.
Easily. Let's draw a diagonal. Now this could be either 1 or 2. I'm going to call this D1. And do we know diagonal 2?
We can draw it.
We could easily draw it, of course.
That one's hard.
Do I know my base?
Yes.
Yes. Do I know my altitude?
No.
No. But you realize if I knew my altitude, I could put it anywhere on the base, draw lines to the ends, and I'm done, right? So really, to transform the rhombus into a triangle that's twice as large, I just need to know what the altitude is, right? So I should probably set up a proportion that'll help me to find h. Now, h is not going to be a mean proportional. H could be a fourth proportional, couldn't it? How would I need to set up the proportion?
2d1 gets to be as
H is to D2? Right, we need the H in the 4th spot, don't we? So what has to go in this spot? B. Because the B and H need to stay together. So therefore, in these spots, we could put
2d1, d2.
the 2D1 and the D2. Realize if we could construct this, I could find H, and then I could put H on my base and I'd be done, right? So somehow, some way, I've got to be able to construct that. Well, how do we construct the 4th proportional? We draw 2 long lines that form the sides of a triangle. Do this with me. Now, here's where I'm beginning to worry that I made my rhombus too big.
Me too.
Because somehow, you know what? I am rethinking the size of my rhombus very much right now.
Me too.
Any of you, how many say, no, my rhombus isn't too big? How many say, are like me, your rhombus is way too big? All right, for those of us who went way too big on the rhombus, yeah, I didn't think that would, and even my base is awfully ginormous. I'm going to shrink my base a little bit, okay? And I'm going to make a smaller rhombus, because that's going to otherwise be a huge pain, yes. All right, so smaller rhombus this time. Fortunately, it doesn't take long to make a rhombus when you know how. And all of you now know how. Since a rhombus can be a challenging figure to freehand. All right, but remember, I didn't just want the rhombus, I needed its diagonals. Now, since I'm doubling one of them, I'm going to make double the short one, because that always makes life easier.
No,
Doubling the long one just makes things very, very hard. All right, so on my construction now, I've got a little bit more manageable base, a little bit more manageable diagonals. According to my proportion class, the first thing I need to measure and mark off is my base. So let's measure and mark off the base. I've got a feeling I'm still in trouble.
Me too.
Okay.
I'm always in trouble.
So there's the base. And now I need to mark off 2 diagonals. Maybe I should, you know what the problem is that I did the whole double thing. I did the double thing to avoid doing a perpendicular bisector, right? Maybe if I hadn't multiplied both sides by 2, I would have had to do a perpendicular bisector, yes, but I would have had an easier time on the rest of the construction, so I think I may have overthought this one. All right, next we need to mark off what?
2D1.
2 different diagonal ones, so 2 of the short diagonals. Oh boy, this just fit on the chalkboard. Even if you don't fit on the line, just fit on the chalkboard.
Yeah, right.
Come on.
Wow.
Woo! Just barely. All right, so I got lucky. Now realize this point here is only for reference for the first D, so this is not a point of interest here. But if we extend the side here down here is the point I want. So here's the end of B, and all the way down here, just fitting on the chalkboard, is the other end of the 2D1. All right, then what?
Draw a smaller rhombus.
No, we're good. Mine fit.
D2 on the other side.
D2, but on the other side. So measure the long diagonal now. Mark it off on the other side. Oh no. Oh no.
I'm in danger.
I think I'm gonna just miss it. That's my feeling here. So there's my D2, and so now of course, class, we need to connect those dots, right? And unfortunately, it looks like my line goes slightly downward,
It's not going very well.
which means this one would have to go slightly downward, but we both know it can. So if you can fit it on your paper, okay, then go ahead and make the parallel, right? So we would make the arc, and we'd come down here and we would make the arc, and we would measure across, and in my case, we would try to measure across, but of course, that just hits the chalk tray here. And so we'd have to connect the dots, and when I connect the dots, it would come to just a little bit below the chalk tray here. So I'm gonna measure as if we were just trying to get below the chalk tray. Let's just suppose, hypothetically, that that's the altitude, okay? What would I do to finish the construction?
Okay, altitude somewhere on the base.
Good, I put the altitude somewhere on the base. Now what I would do, since I happen to have my fake measurement here, is I just pick a random point and I make my arc. But of course, I can't just draw any line up here to my altitude. The altitude has to be altitude. What's the word altitude mean? Perpendicular. So I'll have to put the perpendicular that goes up there. So I'm gonna make the little marks and open the compass up again, make little marks. When we connect the dots, my my altitude comes all the way up here. Maybe I should have made the triangle half as large. Yeah, that would have worked better. I don't know. All right, so there's my perpendicular. And then, since this is the top of my triangle, we would simply connect it down to here and down to here. And since I did estimate, I can't say conclusively it's twice as large, but it's really close to twice as big as this rhombus. The point I wanted to make is, and maybe it was poorly made in this case, you can do a lot of different constructions with area formulas, transforming things. If you know, well, for the sake of a square, where you're going to have a mean proportional, constructing mean proportionals, or in some cases, fourth proportionals. Questions on this? No, it didn't turn out as good as we wanted, but questions on this? You have a headache now.
Yeah,
All right.
it's auto is saying lose some, you lose some.
It is true. You do lose some, lose some. All right, well, we're going to begin in the next few minutes a review game that's going to take place over the next several days. Okay, but I'm going to divide you up into teams. Now, Audrey is with us today, but the rest of the week she won't be. So I'm going to put her on a team, but realize she's not going to be on that team very long.
Shame.
Sorry, Audrey. Now, unless you wanted to come to school just for the review game, so you know, felt the camaraderie and didn't let your team down. No, you don't want to do that. Okay, so here's what I need you to do. I'm going to have you rearrange your seating just a little bit here. If I could have, you're going to get your stuff on your desk. You're going to be moving, and you'll stay in these seats moving forward. Let's have Jamie, if you'll just slide over one seat in front of Quentin, and then Genesis, if you go around behind the camera, sit right in front of Audrey. All right, and then Chris, if you'll slide over one seat in front of Kendall, and then Ethan, you can actually just slide straight back to Genesis' spot, so that way you're not moving too far there. All right, and you sanitize your hands after class, and don't put your hands in your mouth or touch your eyes throughout the hour so you don't contract the coronavirus that your friend just had. Go around behind. Well, I mean, you're still going to be touching the desk that no one was sitting at. Is it suffocating in here? Anyone else? Anyone else burning up? You're both wearing hoodies. All right. If you would take out 2 sheets of paper, 2 sheets of paper. The goal of this, the paper, is you can write down anything I ask that you do not know. So anything that I ask that you do not know, you will write down on your paper. If you know something today, you'll probably know it Thursday. You probably don't need to write the term down. Don't try to write down definitions. Just write down terms for your own sake, so that way we can move quickly. Or maybe shorthand, jot down real quick a key idea of a principle rather than actually trying to write the whole thing out. You just don't have time for that. So just have a couple sheets of paper for your exam review. So how this will work? We'll have the first 2 people compete against each other, which would be Jamie and Ethan. They'll compete against each other. And then if neither of them knows the answer, I'll wait long enough to confirm you. Neither of them got it. And when I say next 2, that'll go to Quentin and Chris. So next people be ready to answer in case the people in front of you can't. However, if even the next people won't, I'll just say anyone and others, no point available. All right, so let's have this group, since there's 4 of you, you can be the quadrilaterals, or we'll say the quads. And since these people, there's 3 of them, you can have the tries. The tryhards?
Hey, I'm the only tryhard.
The tryhards. And the quads. Anyway, we can come up with more creative names later if we so desire. Now, the way this will work, since it's first 2, at any point, as I say the question, you can interrupt with what you think the answer may be. However, once I hear you start to answer, I will stop saying the question. Okay, so you can blurt out the answer first to people, but I will stop. If you happen to guess right, more power to you. But if you guess wrong, I'll finish the question and then go to the other person. So, all right, so here we go. What do we call the instrument used to draw straight lines? Straight edge. All right, next 2. Next 2, Quentin and Chris. The shortest distance between 2 points is? Straight line.
What?
That was definitely Quentin, but it's okay.
I couldn't hear him, sorry. You gotta talk louder so I can hear you. All right, 2 straight lines can intersect at?
1 point.
1 point. Audrey and Ethan. The point that divides a line into 2 equal segments.
Perpendicular.
Who?
Perpendicular.
Point that divides a line into 2 equal segments.
Oh yeah, no.
Next 2.
Bisector.
No.
Anyone?
Midpoint.
Midpoint, no point. Midpoint.
Oh,
Geometric instrument, let's see, hold on. So we're to Quentin and Kendall. Geometric instrument used to measure line segments. Compass. Compass. All right, Ethan and Genesis. Limited portion of a line.
Segment.
Line segment. All right, we're to Chris and Audrey. Line segments are equal if their blank can be made to coincide.
If they're endpoints.
Endpoints can be made to coincide. Jamie and Kendall. Lines or figures formed using only a compass and straight edge. Constructions. Constructions. All right. Back to Ethan and Quentin. The whole is equal to?
Some of these parts.
I think he finished just before you there, Quentin. And you're right, sum of all its parts.
feel like some mask bias over here.
No, I heard him clearly. I heard him great. It's just like, okay, they both started about the same time, but I think he finished saying the word parts before he did.
Scream next time.
All right. No, I heard him fine. Let's see. If the first of three quantities is greater than the second, and the second is greater than the third,
And the first greater than the third.
first is greater than the third. All right. Ladies in the back. What do we call a figure formed by two straight lines drawn from the same point? Two straight lines drawn from the same point. Next two front people.
Angle?
Angle. An angle. All right. Next two. So Chris and Quentin. What do we call the line through the vertex of an angle that divides it into two equal angles? Is an angle bisector. All right. An angle whose sides make one complete revolution. Paragon. Front and back. Angles that have the same vertex and a common side between them. Next two. Anyone? Adjacent angles. Jot that term down. Adjacent angles. Angle formed. Let's see, we're two now. Quentin and Chris. Angle formed when two straight lines meet to form equal adjacent angles.
Vertex angles? No, wait, no, it's right angles.
It is right angles.
Oh, so you can't change your answers.
Sure. I mean, it's not like he hadn't said anything yet, so. All right, lines that meet to form right angles.
Right
Next
lines.
two. Perpendicular lines.
Right.
Perpendicular lines. You're after Kendall.
Oh.
All right. All right, it's Jamie and Chris. An angle that is less than a right angle. I think he finished before you, Jamie. Quentin Kendall. An angle that is greater than a straight angle but less than a paragon. Reflex. Ethan Genesis. Two angles whose sum is a straight angle.
Paragon.
Next two.
Sum is a straight angle?
Sum is a straight angle.
Supplementary.
Supplementary
Oh,
angles.
yes.
Supplementary
I'll remember all
angles.
this.
Next two, we're to the back, ladies, again. When two straight lines intersect, the non-adjacent angles are called front people?
Vertical?
Vertical angles. Vertical angles. All right, second people in each row there. What is 1/360th of a paragon?
1/360 for a paragon? Second. 1 degree.
10?
1 degree.
Degree. A degree is correct. What do we call the instrument next to used to measure angles? Protractor. It's not a geometric instrument, but it's still the instrument used to measure angles. Front and back in this case. What do we call two angles whose sum is a right angle?
Complementary.
He finished before you. Complementary, and that is all we have time for today. So we have the tryhards sitting at 12 right now, and the quads at 9. We will resume.
Yeah, that was on me.
We will resume this competition in our next lesson. Have a wonderful rest of your day. Your only homework will be to study. And make sure your notebook's ready to go for Thursday, lessons 175, when you take your exam.